So today we are going to start about the storage option that we can use with the EC2 instances. So first, the most important one are going to be the EVS volumes. So let's define what they are. So EVS volume stands for the elastic block storage. It is like a network device that we can attach to our instances while they run, and we have been using like till now also we are using them. So the EVS volumes allows us to process the data even after your instance is terminated. So basically, if I explain you in a very simple term, EVS volume is like the external hard drives that we attach to our laptops. So if something goes wrong to your something happens wrong with your laptop, then also in that case, whatever data you have in your external hard disk, that will be persisted. And now you can detach it from your laptop, you can attach it to another laptop. So EVS volume are same like that. So we can recreate another instance and mount the same EVS volume from before, and we will get back our data. And this is like very helpful. So at one point of time, they are mounted to only one instance, but you can detach these EVS volume from our one instance, and then you can attach it to another instance. And when we create an EVS volume, it is bound to a specific availability zone. So what does this mean is, you can create EC2 instance and EVS volume separately. But what happens, we saw in the case of network interface card also. If you are creating your EVS volume in US East 1A availability zone, then to attach to an instance, that instance should also be in the same availability zone. That means that we cannot have an EVS volume created in US East 1A and you have an instance that is in different availability zone. We cannot do that. So as I said, we can think of them as a network USB sticks. So it's a USB stick that you can take from a computer, put it in another computer, but you do not actually physically put it in a computer. It is attached through the network. So currently in a free tier, we can get 30 GB of free EVS storage of type general purpose or SSD or magnetic per month. So this is the basics of the EVS volume.
I have a quick question.
Yeah.
Sorry. So, like a regular computer, when you purchase a regular computer, we have a hard drive, right?
Correct. Yep.
So, what happened with the EC2? Does it come with some small hard drive? Then we attach the external EBS. Like that, how it works? Like
okay. So yeah, you answered the question itself. So when you create an EC2 instance, okay. So when you create an EC2 instance, when you create an EC2 instance, let's say this is your EC2 instance, by default, it will be created something we call it as a root volume.
what is called a root volume.
Yes, this is called the root volume. This, when you create your EC2 instance, this is going to create alongside with your root volume. Again, this is also a EVS, but the life cycle of the root volume is with your EC2 instance. Okay. And here also you can define the size of it, like whatever you want, that you can do. Now, apart from the root volume, any other volume that you need. So like say if you created a Windows-based computer and you want to have a C drive, D drive, E drive, so then you attach the EVS volumes to them. Now,
okay, sounds good.
Okay, now again, this root volume is also the EVS volume, but the life cycle of the root volume will be with EC2. So if you're deleting your EC2, this root volume will also be deleted, but EVS volume will not be deleted, which you are attaching after creation of your EC2 instance. Okay.
Well, thank you. Just wanted to clarify. These are the concepts.
Yes.
Yeah, I had something.
Right. So it is a network device, and It uses the network to communicate to the instances, uh, and it can be detached from an EC2 instance and attached to another one. Second point, it is logged to an availability zone. So we discussed all this also. So if you're creating an EC2 instance in one particular availability zone, you can attach only EBS volumes which are present in the same availability zone. Okay. So second point is to move a volume across, you first need to snapshot it. So we will discuss more on that in the uh, subsequent slide. So snapshot is basically like you have a EBS volume. Okay. Now if you want to copy it, so snapshot is like a backup. So whatever data is there in your EBS volume, you can take a snapshot of it. Then it has a provisioned capacity. So while creating the EBS volume, you need to define their capacity. Okay. So let's say if I'm going to create the 30 GB EBS or 100 GB EBS or whatever the size is. So now once you create the EBS, so let's say if I created a 50 GB EBS, I will be charged for it because I already created it, right? Now, if you are using the data or not, it is up to you. So let's say if you created a 50 GB EBS volume and you are just using the 10 GB, 40 GB is available, that does not matter. You will be charged for the 50 GB. So, and second point is you can start from the smaller number and then you can increase the capacity of the drive over time. So let's say you can, if you're seeing the scenario. So for the cost optimization, what you can do is you can start, let's say for example, 15 GB, and then eventually you can increase it to 30 GB, then 40 GB, and then 50 GB. So from the initial, from the starting, you do not need to pay all the amount. Okay. And here you can see EBS volume. First is like they are bound to an availability zone. That is the first thing. Second is one EC2 instance. So one EC2 instance can have a one EBS volume. One EC2 instance can have a multiple EBS volume. And if you want, there could be like no EBS volume attached to your EC2 instance as well. So that is up to you, like what is your requirement, what data you want to store. If you want to store it in a single drive, you want to store it in a different drive. So all these combination you can basically do. Now there is a very important attribute is available in EBS volume that we say delete on termination. Okay, so what does it means is it controls the EBS behavior when an EC2 instance terminates. By default, root EBS volume is deleted because why the life cycle of the root volume is associated with the EC2 instance, because by default, this delete on termination button is enabled for them. If we disable this button for the root volume also, so then root volume, you can process the data whatever is there in the root volume also. By default, any other EBS volume is not deleted because the attribute is disabled. So for if we discuss about this diagram, like we say the life cycle of the EBS volume is independent of the EC2 instance. But if we enable this delete on termination, attribute for this EBS also, then it will also be deleted when we are terminating our EC2 instance as well. So the life cycle completely depends on only on one parameter, that is delete on termination. Now this can be controlled by console or the CLI, and use cases is it prevents root volume. You can preserve your root volume when the instance is getting terminated. Okay. Let's see this from the console. I'll say EBS demo, keeping everything same. Now you see, we have not selected any EVS related, any storage related thing, but by default, a root volume will be created for you. So we can see this. And if you go to storage, so you can see the volume is created for you. It is also an EVS volume, but it acts as a root device. Okay, so the volume size is 8 GB. Attachment is attached, and delete or termination is yes. Okay, so that is the reason if I terminate this EC2 instance, this volume will be deleted. How you can create more volumes is you need to go to EBS and click on the volumes. And here I am going to see this volume here, 8 GB and all of these things. Now what I can do is I can create a volume. So let me see in which availability zone. So this is in the EU North 1B. So there is different type of volume we will cover later, but here you can define the size. Let's say I am defining the 50 GB. So you can see minimum 1 GB and the maximum is 16,834 GB. So IOPS and throughput also we can define, and we need to select the availability zone. I'll select 1B only and I'll create the volume. Now here if you see, let's say I gave some name, secondary. Now if you see the size is 15 GB, IOPS and all of this, it's getting created. And here if you click on the volume and we can create a snapshot out of it, we can detach this volume and you can modify your volume also. So let this volume, yeah, you're asking something?
Yeah. So how do you attach that newly created volume to
Yes,
the
yes,
EC?
yes, I'm coming to that. So now this volume is created, right? So you need to attach it. So there is an option of attach volume. Okay, so once you attach it, now as we say, the instance should be in the same availability zone. Now I know my instance is running in this availability zone. I'll select my instance. You can say dev //sdf. So the volume is attached. Now if you see the volume, it says in use. Okay, and if I go to my instance type, EVS demo, and here if you see in the storage, now you can see there are two volumes. One is the 8 GB size and another is the 15 GB size. Okay, so now this volume is attached to the EC2 instance, but we cannot still use it. So to use this volume, what you need to do is, okay, so if you see df-h, I'm not still seeing my volume. So we have created an EVS volume, we have attached uh, to the volume. Now we need to make it available. So there is like these steps will be depend on your operating system. So if you do it in the Windows, then there will be other commands to use it. But I am showing you for the Linux. So there is a command for slblk. So this is you can see this is my drive 15 GB which is available to use. So what we will do is we will create a file system on this machine, make dir-p. Let's say I'm giving any name, mnt EBS volume. Okay. Now we need to create the file system. So sudo make file system hyphen text4, and what name we have given to our volume? What was the device? Let me see. We have gave some name.
I think you give secondary, right? Or
No. That was the name. I have given some name. Check it. No, I think we cannot. Let me create and attach it. While attaching, I have given so. Here I have given this name. Let it create it. Yeah. Attach volume. Here device name. So, this got created in attach. EU not 1A. Dev SDG. This is the device name. I will copy this. Okay. Now, if I run this LSBLK, you can see now there is a disk attached 100 GB as well. Right. This disk available to use, which is 100 GB, and you can see it creating file system with the 4K blocks and this and this. It has created a file system. Now we need to mount this file system to any of the file system that is available on system. Right. So for that, what we do is to mount tab SDG. So currently, if you see in df-kh, you are not going to find this volume, only this 6.5 gigabyte. This is the root volume. To use it first, we need to mount this volume to this EC2 instance, then only we will be able to use it. So we just simply need to run the mount command, sudo mount, and what was the name of my device? Copy, paste, and I created one file. Right. So I'm mounting this file system that is available on my server to this EBS volume. Okay. Now if I run df-th again, you can find out here that this is mounted to mount EBS volume. So whatever now I am going to written here in this EBS volume, you are going to see there is nothing, but let's say I will create file 1, file 2. Okay. So these two files has been created. Now what we will do is we can delete this instance. So we will see once you are deleting your instance, you're terminating your instance, your root volume will be deleted, but this is the volume that is not going to be deleted. So you go to instance state, terminate, and if you go shutting down, once it is terminated, then we will see. If you go to EBS volume now, currently we have 3 because it is getting terminated. So this volume will get deleted. You can see now only the external volumes are available. Whichever was the root volume has been deleted. Let me delete this volume also. And if your volume is attached to any of the EC2 instance, you cannot delete that volume. Now this is one way of attaching the volume. Secondly, we can attach the volumes while launching the instance itself. I'm creating the instance with the same name, but here if you go in storage, right? So this is your root volume. You can give any size here, right? Secondly, you can add a new volume that will create a new volume to you. And if you go to advanced, so you can like here you can set up this attribute delete on termination, yes or no. So if you select this delete on termination, you see for the root volume it is always yes, but if you're creating any other volume, then the delete or termination is no. So that is the reason that that is the main reason that the life cycle of the EBS volume is dependent on the root volume is dependent on that, but otherwise it will be on to the. So I'll select the I will edit this and I will make sure that it is going to be created in the EU North 1B only because my EBS volume is in that region.
Quick question, like, so if you have an existing EBS volume, can you attach that?
Yes, that is what I'm showing. That is what I'm showing. So currently we have this EBS volume, right? And now we have created this EC2 instance, correct? So once it is up and running, now I can go to the volumes and you can see I have this volume and I can attach this volume to this newly created EC2 instance. So it is used the dev SDF. Now, if you see, if I go to instance and connect to it.
Do I need to do the mounting again or like?
Yes, you need to. Anytime you are attaching a volume to a new instance, you need to mount it. So mounting is happening on the EC2 level. It has nothing to do on the EBS because the EBS volume is present here, right? Now, how you are going to use it, you need to mount it.
So one more question, like when you create an account, when you create an EC2 instance and on that time, if you select, okay, I need an additional EBS, right? Do I do the mounting again or like it does?
No, mounting, yes, you need to do the mounting. If you are attaching EBS volume, so let's say if I attach one more EBS volume, that also you need to mount.
Oh, okay, I see. So it's on
Basically,
manual work.
I'll tell you example. So when you attach a network external hard disk to your laptop, how you are going to use it, that a device name will be created, for example, E drive, F drive. Then only you know how to copy the files to your external drives, right? So it is like automatically mounting it. Now you know this device has 100 GB, but where you are going to write the data so that it is going to create going to copy into this EVS volume.
Okay.
Right. So yeah, make file system hyphen T ext4 sudo.
That means so this EVS volume can be shared with the multiple instances, right?
No, at one point of time, one.
So one by one only. Okay.
One by one. So for example, it is very simple. Like if your hard disk is attached to your laptop, right? Then you cannot attach it to my laptop. You need to detach it from my laptop and then attach it to your laptop. Correct?
Okay.
Yeah. So it's
Okay.
one at a time.
So in that case, right? I mean, from the performance perspective, right? Is it better to have a root with the maximum capacity rather than the EVS, or I mean, what is the purpose of having EVS other than just like the data security things?
Sorry,
Because
can
I
you
mean, yeah. So what is the other benefit having EVS volume, right? So rather than having a large volume in root storage only.
No, so that is a use case. So it is basically a storage device. Okay. So if you want to persist your data, so let's say your application is generating very much logs, right? So then if you want to persist, just a second,
Yeah, that is kind of the data security thing, right? If you have a EVS separately, and if you somehow if you lost the instances, your data will be there, right? In
correct.
EVS volume, right?
Data will be persisted.
Yeah. So my question is, from the performance level, right? Is there any difference having a large volume of root storage rather than the EVS volume?
Okay, I'll tell you. See, if we talk about the performance type, there are different type of EVS volume. Okay, so accordingly you need to select the type. So we will cover the type of the EVS volumes.
Okay.
Yeah, so we will cover that. Now let me mount this sudo mount stf and what was the name that we have given? NVMe. Am I giving a wrong command? We need to give this slash here. So now if I go to those were the temporary file that we lost, but we can see here that this EBS volume, we can attach it to the secondary instance. Now what happens is, at one point of time, let's say you have two EC2 instance, and this is this EBS volume. It can be attached at one point of time to one instance. But let's say you detach it from here, then you can attach it to here. So how we can detach it? Again, very simple. You go to your EBS volume, and this is my volume and action. I am not getting an option of detaching the volume. If you go to instances, okay, and go to storage, is attached, and click here and detach volume, right? So now you detach this volume. Now this volume will be again available for use. So currently it is showing in use, but it will be available. So you can say now it is available. Now I can attach it to any other instance as well. Second thing here is the EBS snapshot. So EBS snapshot make a backup of your EBS volume at a point of time. It is not necessary to detach the volume to the snapshot, but recommended to detach it when you are taking the snapshot, and you can copy the snapshot across the availability zone or the region. Now, snapshot has two use cases. So snapshot has two use cases. One is like the backup. So whatever data that you have, if you want to take the backup of this, then again snapshot is a very good choice. Then the secondly, you, let's say this is one computer, this is running in US East 1, and this is another EC2 US East 2, for example. Now this is attached an EBS volume, and you want to run the similar application for the disaster recovery purpose or for the high availability purpose, right? So you need the same data for this instance as well, maybe some configuration file, whatever it is. Now you cannot directly copy the EBS volume. You cannot. What you need to do, you need to take the snapshot, then you copy the snapshot here, and then from the snapshot you create an EBS volume. Okay, so let's see. So we will go to any drive here.
So that is will be only read only. The snapshot is always read only, or
no, it will not be read only. So I'll show you. So let's say I am taking,
image. Okay, snapshot.
so I am taking a snapshot. You can go to snapshots, create a snapshot. Now you can create a snapshot from a volume. You can create a snapshot from the instance as well. But let's focus on the volume. So we have two volumes. Whichever volume you need to create a snapshot, you click on it and then create a snapshot. Now you can say snapshot is read only. So basically snapshot is a backup, right? Backup is a read only. If you want to use it, you need to restore it. Correct. So now this snapshot is let it be created. So once the snapshot will be created, here currently it is pending. what you can do is you can create a volume from this snapshot. And if you create a volume from this snapshot, your volume will have the same data which you use the volume which has took the snapshot. Okay, so a snapshot, you can say it's a read only because it's a backup. To use the backup, you need to restore it in the form of a volume. Now you create another volume, and that volume you can attach it to any of the EC2 instance. Second is you can copy this snapshot. Now you can copy this snapshot. Now I can copy this snapshot, you can see, in any of the regions. So let's say I'm copying it in the AP South 1 and copy snapshot. Okay. Now if I go to AP South 1, you'll see there the copied snapshot is there, and currently it is pending. It's 100 GB, right? And if I click on this, it is still unavailable. So once it is in available status, you can create a volume from this snapshot. So this volume will have exactly the same data for what we use from the base volume from which we have created the snapshot. So the snapshot is very helpful in transferring the data from one region to another region as well. Okay, so these are the two use cases of the snapshot. In which region we were? Okay.
So how will the replication take place here in these two multiple snapshots and the original EBS volume?
I'm
So
sorry.
how is it? How the replication is working on this scenario?
No,
Replication now the sync, right? So it should be sync, right? Between
no.
Okay.
It is not. It is not. The data is not replicating anywhere. So, for example, a snapshot works on. Let's say this is your EBS volume. Okay, at 10 a.m. you have taken a snapshot.
Okay.
For example, now at 10 a.m. whatever data will be here, that will be there in that snapshot. That is first thing. Now, at 10:30, in the same EBS volume, you have put up some more data. Now that data, this red data will not be in this snapshot one. You need to take again a snapshot.
Okay.
So a snapshot is basically, it is like taking the current state, whatever, at what time you are taking a snapshot, at that point of time, whatever data is there, it will come in the snapshot. So you can, we can basically do this automation, right? So generally what companies do is, let's say daily 6 a.m. they have create some automation which is taking the snapshot of all your databases, not databases, but all your EBS volumes. So based on requirement, you can set up all these automations also. But a snapshot, you need to understand that a snapshot is like the current state, whatever at the time of taking the snapshot. If after some time something had changed, let's say you deleted some data, right? So your snapshot will have all the data, but the current state will not have all the data. So now you need to restore. You can restore from the snapshot. So snapshot is like, it's a snap. So whatever your EVS volume is doing at this particular point of time will be there in the snapshot.
Okay, so the snapshot basically is not a real time.
No. It's not a. It has nothing to do with the replication. It is like you copied the current state of your system into a drive and call it as a backup. Now, if you want to update that backup, you need to take a second snapshot.
Yeah, that is clear to me. Thanks.
Yeah. Okay. Now we have this snapshot feature as well, snapshot archive as well. So what happens in the snapshot also, uh, let's say, as I said, most of the companies, they take backup on a daily basis, on a weekly basis, like based on the application criticality. Now what happens is, let's say after some time you will have multiple backups. Now you do not want to use them, but you want to keep them for the compliance purpose, so that if something very goes wrong, then you can recover from it. So if you keep all of your snapshot in the normal in a normal way, then it is going to cost you very much. So there is another tier in the snapshot, that is snapshot archive. Okay, so you can set up the lifecycle rule that we set up in the S3, and this will move your snapshot to the snapshot archive. So let's say what I'm saying, after 1 month, so whatever snapshot that is more than 1 month old, you can move it to the EVS snapshot archive. Okay, so that way you can uh, do the cost optimization, and it will be 75% cheaper comparison to the normal snapshot tier, but it will take around 24 to 72 hours for restoring the archive. Okay, so once the snapshot goes into the archive tier, it is going to take some time. It is going to take some time to retrieve it. So you can have all the current backups in the EVS snapshot tiers, then all the old backup you can go and create in the EVS snapshot archive tier. Then we have the recycle bin for the EVS snapshot, and in the recycle bin you can set up the rules to retain deleted snapshot, so that you can recover them after an accidental deletion, and you can specify the retention period. So after, like, let's say you deleted a snapshot, that goes to the recycle bin. Okay, and let's say till 1 year you are not retrieving it, you are not restoring it, then it will completely be deleted. Okay, then we have one more feature called the fast snapshot restore, and it basically do the full forceful initialization of snapshot to have no latency of on the first use. So there is an option of the recycle bin, and here we can create the retention rule. So retention setting, so EVS snapshot or the AMI, and let's say you say apply to all the resources, then you can select the retention period. Okay, the retention rule can be modified or deleted at any time by a user with the required permission. The retention rule can't be modified or deleted until is unlocked by the user with the record. So you can basically log these retention rule. So if I set it to 1 day, in you deleted one snapshot and you are not restoring it in 1 day, then it will be gone completely. So you can, let's say, create those retention rules. So any sort of data that you are creating, and if you go to resources, currently no resource. So let's say, let's go to the EVS snapshot and delete this. So after some time, it will come here, and it will take some time, 5-10 minutes. And once this resource is there, so then you select that resource and you recover it. So this is basically a protection from the accidental deletion. So it will take some time, and so that is the purpose of the recycle bin. Okay, now this is a very interesting thing, AMI. Okay, now what is an AMI? As its name suggesting, AMI is a Amazon machine image. AMI is basically a customization of an EC2 instance. We can add our own software, configuration, operating system, anything that you, let's say you're supposed to do, we can do it with the help of AMI. Now, why you are going to use AMI? For the faster boot configuration time, because all your software is pre-packaged. Again, AMI is built for a specific region. Okay, so if you created an AMI, you are going to create the instance out of that AMI in that particular region only. So we can launch an EC2 instance from a public AMI that AWS is provided, your own AMI, we can maintain them ourselves, and in the AWS Marketplace AMI. So we will do this from the complete demo. So let me go to EC2. So let me delete this. Okay. Now what I'll do is I'll launch another instance and I'll say this is AMI demo. Now see, the first thing that you need to select while launching an instance is the Amazon machine image. So you can see these are the public AMIs like Linux is there, Mac OS is there, Ubuntu, Windows, Red Hat, and there's so many others as well. Now you can browse more AMIs. So currently you see quick start AMI. So for all the operating system, there will be AMIs is available. Amazon Linux, Mac OS, Sonoma, Ventura, other like so many images will be available. And then there is something called the marketplace AMIs. Okay, so marketplace AMIs are basically, let's say there is a particular product. Now that product you want to run on AWS. So the official vendor itself is giving you those AMIs. So if I go to AMI, AWS Marketplace AMI, and let's say I want to run Tomcat. So most probably there will be an AMI available for Tomcat. So you can see now Apache Tomcat server on Windows 2019, Tomcat server on Ubuntu. So you can see there's so many links are available, right? And most of the common softwares you will find in. So what does this mean is that once you launch your EC2 instance with this EMI, the Apache Tomcat server will already be installed on it. Okay, so for most of the daily whatever the software is being used, most of them AMIs will be available. So instead of configuring and using the software, so you can see Splunk is available and it is by the Splunk only, right? So for if I say, for example, ELK, Elastic, so you can say use ELK stack is there, Bitnami package for ELK. So there's so many AMI available on the marketplace. Now after that, there is something called My AMIs. My AMI is, let's say you're running a custom application and you want to, for example, you want to have, let's say there is a requirement of, that you need to create an EC2 instance and you need to install Java, HTTPD, and other details basically. And you need to do it on the 100 server. 100, you need to create 100 EC2. So one way is you create 100 EC2 and then you go manually on all of the instance and you are doing it. And now this will be a very time consuming process. So what you can do, and the most effective way of doing this is I create one EC2 instance, only one EC2 instance, do all the configuration on this EC2 instance, and I am going to create an AMI out of it. So that will be custom AMI, which has Java plus HTTPD. And I launch 99 instance from this AMI. So I do not need to configure anything on the remaining 99 instances. That will be configured in the AMI itself. Okay, so that is the purpose of the AMI. So let's see. So right now I will be selecting this. Okay, and I go t3.micro and EC2 demo. Okay, it's running. Let me connect to it. Okay, so now if I say Java, so there is no Java. So I will install the Java on this. So sudo yum install Java. Okay, now if you run Java hyphen version, so you can see Java is installed. Similarly, I will install HTTPD, for example. Okay, sudo systemctl enable HTTPD, and let's see, start this, and if you see the status, it should be up and running. Okay, now what I'll do is I will create an AMI out of it. So you go instance action. So you see there is an option of creating an image. So I'll create an image. I'll say AMI demo, for example, and everything remain the same, and I'll say create image. Okay, now if you go to AMIs, then AMI demo has been created, and it will take a minute to become uh, active, available, and you can see the visibility of this image is private. Okay, and there is an option of launch the instance from AMI. So let it be available in a minute. So all these things are similar. Recycle bin is the same recycle bin for EVS snapshot and AMIs. Similarly, we can copy this AMI to another region. So there is an option of copy the AMI. So you can copy this AMI, same format, exactly like the app. So you need to select the destination region, and you can create the instances in the another region. So AMI is one thing you can do for the customization, and the second thing is, again, we have seen in the snapshot. Let's say your EC2 is running here with some custom software, right? Now you want to deploy similar EC2 instance in another region. So one way is you manually configure those, but like in manual configuration, you might make some mistakes. So what you need to do is you create an AMI out of it. You copy the AMI in the destination region, and then you launch the instance from this particular AMI.
Check, I have a question in the meantime.
Yep. Yeah.
So you launch a new instance from the AMI, right?
Mhm.
Let's say the initial one, we had the server running, right? HTTP server, right? It's running. So keep when you get a snapshot and restore, I mean, create a new instance from the snapshot, is that snapshot the server will automatically run, or is it gonna automatically start, or like we need to go and manually start it?
No, we need to manually start it. See, it will depend on application to application. So if you give up all the servers that is installed on the base server, on the software, those will be start. But for the some application, you need to start your application manually.
Yeah, for example, when you take the snapshot, you kind of started the HTTP server, right?
Yeah,
and
yeah.
you took the snapshot.
Yes.
So now if I create another instance from this snapshot, I just want to see like whether the server automatically started HTTP or like.
Yeah, let's see. So now there is two way of launching the instance from the AMI. Either you can go to the AMI space, and here you know that this is your AMI. I will select it and launch the instance from AMI. Right. Second is you go to your instances, similar way, launch the instance, and here I give any name, and here you see there is an option of my AMIs. So you click on the my AMIs, and there whatever AMI you will be created, that will show you here. Okay, so I'll launch the instance with this. Okay, now you see we will see first for the Java hyphen version. You can see Java is already installed. Second thing is systemctl status httpd. See, it is running.
So whatever I mean,
no,
whatever
I'll
was doing,
I'll tell you. So see, when I was on my base server,
it was running.
It is running. What I wanted to show you. See, this is a command. Sudo system enable httpd. So what this command does is, whenever your system will restart or reboot, basically, whenever your system boots, because after the first time it is rebooting, right? So whenever your system boots up, whatever services are enabled, that will be started. It is like when your computer runs, some services automatically start. So if I do not enable this service and create an AMI, then your Apache will be installed, but it will not be started. So it will depend. Okay, it will depend how you are configuring your AMI so that your application is coming up or not. Application will be installed for sure, but if they come up or not will depend on how you are configuring it.
Makes sense.
Yeah. Okay.
Thanks.
So if I do not run this command, then on my second server, it is not going to come up. It will just install, then we need to manually start it. So we have seen this. Okay. So there is something called as the EC2 instance store as well. It is like the RAM. So we have seen in the hibernation as well. So EVS volume are the network device with good but limited performance. So if you need a high performance hardware disk, we are going to use the EC2 instance store. It has a better IO performance. EC2 instance storage are ephemeral in nature. So once you are stopping your instance, whatever data is going to be there in the instance store, it will be lost. So it is good for buffer, cache, scratch data, and for the temporary content. Risk of data loss if hardware fails, and backup and replication are your responsibility. So we generally do not use it because it is ephemeral in nature. But for the time being, if you want to use it for the temporary data, then you can use it. So from the examination point of view, this is very important, where we can say they will give you a scenario, and they want their requirement is not to persist the data, but a high performance solution, right? So in that case, you are going to use the EC2 instance store. So you can have very high input output per second with the local EC2 instance store, and these are some numbers. So it is not very important.
How do you when you select the EBS, you select this type?
No,
or
so
like
we select these types. Okay, now you see EBS volume comes in 6 types. Okay, GP2, GP3, that is SSD, solid state drive. Then we have IO1, IO2, SSD, and then we have ST, HDD, and SC1. Okay, so when you create an EBS volume, so if I go and let's say I'm creating a volume, so then you need to select the volume type. So there is general purpose SSD, GP2 and GP3, IO1 SSD, IO2 SSD, then SC1, ST1, and then in the last we have the magnetic one. Okay, let's see. So GP2 and GP3 are the general purpose SSD volume that balance price and performance for a wide variety of the workload. So if you're not sure which type of EBS volume you need to use, you can use the GP2 or GP3. GP2 was the previous generation, GP3 is the latest generation. But your application workload, which are very critical, like the databases application, where there is multiple read-write operation happening per second, then you should prefer the IO1 or the IO2 type of the EBS volume. So IO1 is the highest performance SSD volume for the mission critical low latency or high throughput workload. So if you are very concerned about the performance, then you need to select the IO type of volume. Now IO1 is the previous generation, IO2 is the latest generation. Then in the last we have the HDD. These are the lower performing volumes which you can use for the data which is not very frequently used. For example, like all the backups, archive, very older data you can store in the these hard disk drive, and these is like very cheap in comparison to GP2 or IO generation. So ST1 is a low cost hard disk drive volume designed for frequently access throughput intensive workload, while ST1 HDD is the lowest cost HSD volume designed for the less frequently accessed workload. So EBS volume are characterized in size, throughput, and IO ups. So we can always refer for the documentation if you are not sure about the numbers and all. So, and because these numbers also, like what is the IO ups for GP2, IO1, this is also going to be changed. Now, very important thing is only GP2, GP3, IO1, IO2 can be used as a boot volume, or we can say as a root volume. So we cannot have a root volume which is ST1 STD or SC1 STD. Okay. Now these are
one question. Sorry, can you go back one slide? Yeah. So the IO1 and IO2, right? High performance SSD. I'm assuming like when you say, okay, I have an EC2 instance, and inside the EC2 instance, I would like to install the MySQL, for example, right?
Yeah.
I should use that, right?
I should use that. Yes, exactly. So we have in the coming slide, we have some use cases or some numbers regarding these volumes. So, okay. So this is a general purpose SSD. It is a cost effective storage, low latency, system boot volumes, virtual desktop, development and test environment. Now you can see the limit of general purpose SSD is 1 GB to 16 TB. So you cannot go beyond 16 TB in general purpose SSD. Now in general purpose, there are two generation, GP2 or GP3. Okay. Now these are the numbers. So baseline of 3000 IOFs and throughput of 125 megabyte per second. And we can increase up to 16,000 IOFs and throughput 2000. While GP2 only 3000 size the volume and IOPS are linked. Max IOPS is 16,000. 3 IOPS per GB means at 5000 GB we are at the max IOPS. So now again, don't need to remember this number, just for the understanding, because no one is going to test you on the numbers, because anytime you are going to create an architecture, these numbers you can refer from the AWS documentation. But here you need to understand one thing, that like if your data is more than 5000 GB, then it is better to use the GP3 type of a volume, GP3 generation, because the performance of the GP2 will be at the maximum IOPS at the 5000 GBs, 5334 GB. Then we have the provisioned SSD. So if you're running a critical business application with sustained IOPS performance, you need to use this provision. Now there is a very clear demarcation. If you need an application that is more than 16,000 IOPS, then you need to go IO1 or IO2. If you need a less than 60,000 IOPS, you can go for the GP2 or GP3. So it is great for the database workload. It is already stating this. Sensitive to the storage performance and for the consistency. And there is max IOPS is till 60,000 IOPS per second for the Nitro EC2 instance and 30,000 for the other EC2 instance. And we can increase it. IO2 have more durability and more IOPS than the IO1. And see, because it is like the newer generation will always have some better things to do. And in that we have a block express also, sub millisecond latency, and then the IOPS goes up to 256K. So these are some number. And there is very important thing which is says it supports the EBS multi-attach. So we will be having a slide on EBS multi-attach as well. So we will see in that the EBS multi-attach. Then in the last we have this hard disk drive. Now hard disk drive cannot be a boot volume, and again you can go from 125, minimum size is 125 gig to 16 TB, and then you have these two, ST1 and SC1. So large data set which you are using frequently, then you go for the ST1, and the large data set which you are not using very frequently, you need to go for the old HDD. So instead of remembering the numbers, we need to understand the use case, because in the examination, questions can be on the use case. So for example, they will give you a scenario where they are saying, I need to store the backup data, which is more than 1 year old, and I'm not very frequently will be accessing a data. So what is the most cost effective block device I should be using? So you should select that. We need to select the cold STD. So use case is more important than your numbers. So this is just a slide for the summary, whatever we are discussing till now, like what is the durability of this, use cases, low latency interactive as. So you can refer this slide also. So here you can see the multi-attach. Most of the device multi-attach is not supported. Only within the iOS SSD it is supported. Okay. Now what is a multi-attach? We can attach the same EBS volume to multiple EC2 instance in the same availability zone. Now till now what we are discussing, we are saying that if there is EC2 instance, two EC2 instance, and there is one EVS volume, then I can attach this to one EC2 instance only. Till the time I'm not deleting this association, I cannot attach it to the second EC2 instance, for example, right? But this is not the case with the multi-attach. In multi-attach, you can attach an EVS volume to multiple EC2 instance simultaneously. Okay, but all the instance should be in the same availability zone. Each instance will have the full read and write permission to the high performance volume. So you can see up to 16 instance at a time. So here there is only 3 we are showing, but up to 16 EC2 instance, this EVS volume can be attached and must use a file system that is cluster aware. Now that is a Linux kind of a thing. So the use case of this is achieve higher application availability in the cluster application. Application must manage concurrent write application, right? Now there is a catch. You cannot attach multi-attach, you cannot use multi-attach, or if I put it in another words, you can only use multi-attach with IO1, IO2 family. You cannot use multi-attach with GP family or HDD family. So that is one catch. Now there is another catch. So for example, and this is a very common interview question also. Let's say I have 10 EC2 instance. Let's assume this is 5. And now we have a one EVS volume, and EVS volume is IO1, IO2 that supports the multi-attach. And by the definition of multi-attach, I can attach the IO1, IO2 type of EVS volume to multiple EC2 instance up to 16 in same availability zone. But that information is half truth. Okay. So for that, your EC2 instance will also be of the specific category that is a nitro family. If your EC2 instance is like what we are using, like T2.micro, T3.micro, or any other instance like that, then you cannot use EVS volume multi-attach feature. So there is two conditions. EC2 EVS will be IO1, IO2 family, and EC2 is equal to nitro family. Okay, then only you can use multi-attach. So they will give you a scenario where probably either EVS will be from a different family or EC2 will be from the different family. Then they will ask you, probably your question will be like that, that you have multiple EC2 instance, and for that you want to have a common shared storage solution. So can you use multi-attach, or they will give multi-attach in an option. But if your instance is not nitro family, then you cannot use EVS multi-attach feature. So there is other service in AWS, EFS, Elastic File System, that we will see in the subsequent slide. Instead of EVS multi-attach, we are going to use the EFS in that case. Okay. Okay. So now, when you create an encrypted EVS volume, there is things like all your snapshots will be encrypted. All volume created from that snapshot will be encrypted. All data in flight moving between the instance and the volume is encrypted, and data at rest is encrypted inside the volume. Okay, so whatever data you are storing in EVS is completely encrypted. Encryption and decryption are handled very transparently. We have nothing to do. and encryption has a very minimal impact on the latency. So it does not impact your performance as well. And EBS encryption leverages the key from the KMS. Now again, KMS is a different service. It's a key management service from AWS. And so whatever the encryption is happening from an encryption key that is stored in the AWS KMS. And copying an unencrypted snapshot allows the encryption, and a snapshot of the encrypted volume or are always encrypted. So your data is always encrypted whenever we are storing in the EBS. So how we can set up the encryption? So I can show you that. So if you go here, you can see there is an encryption. You can click on encrypting this volume and you need to select a KMS key. So you can see by default, there is a key coming AWS/EBS. So if you select it, so KMS key owner, KMS key ID, KRN, everything you are going to see. And whatever data you are going to store now in the EBS will be encrypted by using this key. If you have your own key, that is also okay. Then your own key, you can specify a custom key also. So you can select a custom key, you give the ARN of the custom key, and then you can encrypt the data using a custom key as well. So now once you select this key, whatever data that you are storing in the EBS volume will be completely encrypted. And when you create a snapshot also from this volume, that snapshot also will be encrypted. Okay. Any question till now? Are we good to start EFS?
Yes.
Okay. Now, as we discussed, like this EBS multi-attach feature is only for a specific EC2 family and specific EBS family. So we cannot, whenever you want to have a shared storage solution, we actually don't think about EBS multi-attach because it has a very specific use case. But let's say you have a cluster of server. This is multiple server, and they want to have one shared common storage solution. Okay, where they will be reading the configuration from the common location. They are writing the logs to the common location, whatever it is. Now you need to, what we can say is, you need to have a shared storage. And that shared storage in Amazon is EFS. That is the elastic file system, which you can attach to the multiple EC2 instances. Okay. Now, Amazon EFS is a managed, or we would say the network file system that can be mounted on many EC2 instances. EFS works with EC2 instance in multiple availability zone. Now that is a very good point. Remember this. So in the EBS, your EBS volume and your EC2 instance should be in the same availability zone. But here that is not the case. EFS, they should be in the same region, but it does not matter if in which availability zone they are. EFS can be mounted. So this is also one way of transferring data from one availability zone to another, right? You can create an EFS and there is two instances. Let's say one instance this, another one this. So you can write the data to EFS and you can read the data from EFS into this location, right? So that is also one of the use case. And the very good thing about elastic file system is it is highly available, it is scalable, and it is little expensive in comparison to, like, you can say 3x in comparison to the GP2. But the very good thing about EFS is its pay per use. What does this mean is, in case of EBS volume, In case of EBS volume, if I create 100 GB volume, right? So then I need to pay for it, pay for 100 GB, even if you are storing only 5 GB data in it. You created a disk and you have to pay for it. But that is not the case for EFS. EFS, whatever data you will be storing. So let's say for 1 month, I store only 1 GB. Then I will be charged only for 1 GB. Then after some time, I add 2 GB more. Then I will be charged for 12 GB. So EFS is pay whatever you are storing. It is not like we do not have to define the capacity that my EFS is 100 GB. No. EFS is whatever data you will put up in the EFS, it will grow in size. Now, the use cases is there could be multiple use cases. Some of them is like web serving, data sharing, multipliers, content management, and it uses the NFS B4.1 protocol. It is compatible with Linux-based AMI. Understand this. It is not used for Windows. It is only for the Linux. And also encryption at rest using the KMS, same as EBS. And it uses the security group to control access to the EFS. So we have seen the security group, and we will see how security group guards the EFS. And it is basically POSIX file system that has a standard file API. File system scales automatically, pay for per use, no capacity planning needed in case of a elastic file system. So there's a different performance and storage classes available in the EFS. Again, don't go with the number, just understand the concept. So EFS scale is a general one where thousands of the concurrent NFS client. NFS client is basically the EC2 instance, and there is 10 GB plus per second throughput we can get, and it grow to petabyte scale network file system automatically. We do not need to get the capacity. Now the performance mode is general purpose, that is default, and then you have the maximum IO. So if you have a latency sensitive use cases such as content management, basically if you're serving the data, then general purpose latency sensitive use case for you. But if you have a higher latency throughput, highly parallel big data use cases, then the max IO performance mode you can select at the time of EFS creation. Then we have the throughput mode. Throughput mode, it is provisioned. Set your throughput regardless of the storage size. And then you have the bursting. Bursting is like for the initial 1 TB, your throughput will be 50 MB per second. And as your storage will grow, your throughput will also be increasing. And it is elastic in nature. It automatically scales throughput up or down based on your workload, up to 3 GB per second for the reads and 1 GB per second for the writes. And elastic you need to use for the unpredictable workloads. Now, similar to the archive tier in the snapshot, we have the storage class in EFS as well. So in the storage tier, we can manage lifecycle management feature. So you can, two tiers are available. One is EFS standard, and then we have the EFS IA, infrequent access. So you can create the lifecycle rules, standard for the frequently accessed file. Infrequent access, cost to retrieve the file, lower price to store. Enable EFS IA with the lifecycle policy. We can do that. And standard multi-AG, great for the production workload. But Bunzone, you can say Bunzone great for dev backup enabled by default and compatible with the Bunzone IA. So there is 90% cost saving if we move between the storage class. Okay, before going to the comparison, let's do the demo of the EFS. So I have one instance, okay, two of them are running. That is good. Now I'll go to EFS. create a file system, and you will see that it is very easy to do EFS demo, and you can select a network, choose the VPC where you want EC2 instance to connect to your file system. By default, it will go as default, but you can select your VPC as well. And then we can customize option as well. So you can have a regional or you have a one zone, enable automatic backups. Then you can select the lifecycle management, transition into the IA, transition into the archive, transition into the right. So we can have enhanced bursting provision, all these performance setting we can select. And apart from it, general purpose recommended, because max IO is not enabled for us because we are using the free tier. And you go to next. So next, and create. Now you see there is no size of this EFS volume. Currently, it is only 6 KB. Okay, because it is dynamic in nature. Whatever data you will store in it, it will grow automatically. So we do not need to worry about the size in case of EFS. And it will give you the complete size in the standard, size in archive, size in IA. So you can move your objects. Then how to attach it to the EC2 instances. Okay. So you can attach it by this. You can mount it via DNS and mount via IP. So if we try to mount it, let's see what happens. So let me connect to both of the instances again. Connect. And I'll go to another instance. Which one did I go to? Instance ID is 606. I do not have instance ID 60. Let me connect it. Okay. Okay, now both of my EC2 is connected. What I'll do is I will create a directory on which I will mount this file system. Okay, similarly, I will do this here. Sudo make dir EFS clear and clear. Now, when I try to mount it, okay, I'll copy this command, simple, and always use the NFS client, because you need to install this EFS utility and all those things. NFS actually by default comes with the Amazon Linux. Why it is giving me this error?
Do you need to put a /EFS?
Maybe. Let me try. Here you're saying?
No. Before EFS, because the initial command has, before EFS another. No.
Here?
Yes. Space. Because initially, and now before now slash. No, space / EFS, because you created the
Okay. I made this mistake several times, and every time I forgot. Yeah. Like this. Now you see it is not happening. Okay, you will get a timeout error. So why it is happening? You will see a timeout error. Okay, now with why it is happening, because in the slide we have discussed EFS is also surrounded by the network security groups. So what is happening currently is, so we understand, right, what is a security group? We have seen this. So what is currently happening is, let's say these are two EC2 instances. Okay, so EC2, EC2. Now these are also guarded by the security groups. And then we have our EFS. And this is also guarded by some security group. Now, when I'm trying to mount the EFS, the request is going to the security group. And by default, we know that security group block all the traffic. So what we need to do, we need to make an entry in this particular security group that whatever traffic coming from these EC2 instance should be allowed. Okay, so currently you see you will get a timeout error probably in some time. So what I will do is I will see what are the security group of my, you go to network and here you see there is a security group. Okay, so I'll copy this, open the notepad. Okay, and I will go get the details of the security group of my instances as well. So it's a launch wizard file. I'll copy this as well, and I will search for another instance. This is AMI demo, and this is demo, for which the security group is, it is security group 6, right? So what I'll do now is I'll go to security groups. So there will be multiple security group, and your EFS is using the default one, which is 60A, right? 60A. Now you see here the connection timed out. Okay, so what I'll do is I'll open the security group. In the inbound rule, I will say allow the traffic, NFS traffic. NFS runs on 2049, and I will give the security group IDs of these. Whatever traffic coming from these security groups, launch wizard 5, I will add another rule for NFS in which I will give the ID of the secondary group, and enter, and I'll save the rule. Now if you try to do it, let me do it. You will see now it is mounted. And now if you see df-kh/EFS has been mounted to this file server. If I go to this directory, ls-lrt, there is nothing. So let's say I create one file, sudo vi file1.txt. Okay, this file I am creating from my first server. Save this. Okay, now if I go to second server, I should be able to see the file and the content. So again, you can see df-kh cd/efs. If you see here, you can see the file1.txt is there, and if I see the content of this file, Okay, this file I am creating from my first server. You can change it from the second server. You see, let's say I'm randomly doing something, and now if you see it from the here, your file will be changed. Now you see. So it's a shared storage drive that you can mount it not up to one, but hundreds of the EC2 instances, but only the Linux based EC2 instances. Clear?
Can I so once I attach to the EFS, can I also do the EBS or no?
Yeah, you can do it. See, EFS and EBS are different things. Okay, so
Okay, so
you can attach multiple EBS device, and also you can attach multiple file EFS also. So let's say I create another file system, and probably I'll say /EFS1/EFS2. So they are not exclusive to one another. You can attach multiple EBS volumes. You can attach multiple EFS in any combination. Okay.
Thanks.
Yeah. Now, if we talk about the difference between the EBS and EFS, so basically, right, EBS volume one instance at a time except multi-attach IU1, IU2 are logged at the availability zone level. EFS is not blocked at the availability zone level. Then you have different families. And to migrate an EBS volume across the availability zone, we need to take a snapshot, restore the snapshot to another availability zone. EBS backups use IO, and you should not run them while your application is handling a lot of traffic. Root EBS volume of instance get terminated by default if the EC2 instances get terminated. We can disable that as well. But if we talk about EFS, we can mount this to hundreds of the instances across availability zone. EFS can share any sort of website file and all this, but the only catch with the EFS is it is only for the Linux instances, and EFS is a higher point in comparison to the EBS, but again, you can optimize it by using the EFS IA for the cost saving purposes.
The instance store, right? Is there any example?
Instance store, we cannot actually, it will not be enabled in the free tier.
Oh, okay, I see.
Yeah, so yeah, that is
especially on the
yeah.
If I like, okay.
Okay, so with that, we cover the EC2 storage options. We cover block storage, EBS volumes, snapshots, AMIs, and in the last, we have covered the EFS. Any question? Then we will move to another topic. We can cover at least theory for this today, and then demo we will see tomorrow. Okay, now the another topic is high availability and scalability, and it would be a very interesting topic. We will see a lot of services in this subtopic. So let's start. Now, what is scalability and what is high availability? And this is also a question when someone in the interview will directly ask you how we are going to implement the scalability, how you are going to implement high availability. What do you mean by high availability? Okay. So first, let's discuss scalability. Scalability means your application is scalable. It means it can scale up or scale down. Okay, so let's say, for example, my website, I have a website and it is on a daily basis handling 10,000 requests. 10,000 users coming to this website, and I have accommodated 5 servers for it. Okay, and it is running fine. But one fine day, I see 50,000 requests are coming. Now, this 5 server cannot handle the 50,000 requests because they are only capable to handle the 10,000 requests. So your system will crash. Now, if your system is scalable, it means it would be able to handle the 50,000 requests as well. So how you are going to do that? We will see that. So scalability means an application system can handle greater loads by adapting. Now there is two kind of scalability: vertical scalability and horizontal scalability. Now, scalability is linked but different to high availability. We will see the difference between the scalability and the high availability. So let's see this more details. Now, what is a vertical scalability? You can see from the diagram as well. Vertical scalability means giving more power to your existing resources. Okay. It is like increasing the size of your instance. So for example, your application runs on the T2.micro. Then, but if I'm saying I'm vertically scaling, it means I'm giving more CPU, more RAM, so that it can handle more requests, right? So probably I will make that as a T2.large, T2.medium. So I am giving more resources to the existing one. So vertical scalability is very common for the non-distributed system, such as databases, RDS elastic cache that can scale vertically. So there will be a limit on how you can do the vertically scale. And I would say, and this is from my personal experience, once you set up your infrastructure, okay, we rarely do the vertical scaling, because once you design your architecture, at that time you know what type of instances size you want, what should be capable enough to handle the load. So, but this is one of the thing we can do, where we can, like, there is a junior operator, we give them a more power and he can become the senior operator. He has more power, he can handle more work requests and all those things. This is called the vertical scalability. Now we have the horizontal scalability. Horizontal scalability means increasing the number of the instances / system on your application. It implies the distributed system, and this is very common for the web application, modern application, and it is easy to horizontally scale. Think like with the help of cloud offerings such as EC2. So horizontal scalability means if you are running with the 5 instances that is handling 10,000 requests, if the more requests is coming, the server number should be increasing. Instead of 5, now there should be 6, then 7, then there is 8, then there is 9, then something like that. And when we do it, so this is a horizontal scalability. And when we do it in the automated manner, it will be called as the auto scaling. Now, what is high availability? Scalability, clear? Any question? Okay. Now, we need to understand high availability. So high availability, like we usually goes hand in hand with the horizontal scaling. High availability means running your application at least in 2 data centers, so that if one of the data center goes down, you have your application running within the another uh, data center. The goal of the high availability is to survive a data center loss. The high availability can be passive or high availability can be active as well. So high availability is like you have a backup, you have a replica of an application running from somewhere else as well, so that if something goes wrong with your primary infrastructure, your application will still keep running. So that is the whole purpose of the high availability. So scalability usually deals with the performance, whereas high availability is mostly deal with the disaster recovery, so that you have at least your application running. So high availability and scalability for the EC2, you in the vertical scaling, you can increase the instance size from T2.nano to anything like from half GB RAM to 1200 TB of RAM. We can do that. Now in the horizontal scaling, we can not only increase the number, but we can decrease the number. So let's say uh, on after the weekend, I got the 50,000 requests. I increase the instances to 10 or 20. Now after weekend, the load is decreasing. So I need to decrease the number of the load, number of the instance. Okay. So with the help of auto scaling group or with the help of load balancer, we will achieve this. And then in the last, we can run our instances for the same application across multiple availability zone, so that if something goes wrong with one availability zone, then my application will keep running within the different availability zone as well. Okay, clear? Any question? Okay. Now, what is load balancing? So we all knows the basic terms of the load balancing. Load balancers are the server that forward the traffic to multiple server downstream. So let's say on these three applications, these three EC2 instance, the same application is running for the high availability purpose. Then these have this IP, this IP, this IP. So instead of giving this three IP, we need a common mechanism for all these server, which will get the request from this end user and then distribute the traffic to the backend server. We call it as a backend system. We can call it as a downstream system, anything. Now, why to use a load balancer? So there is multiple use cases of the load balancer comes. So you can spread your load, and that is the foundation. Okay. So the use of the load balancer is it does the load balancing. It means like it will ensure that if you are running your application with 5 instances, so only 2 instances are not getting overloaded and 3 are underutilized. So it spread load across multiple downstream application, and it exposes a single point of access to your application. Uh, it seamlessly handles the failures of downstream instances. So for example, if one of your instance is going down, then it will make sure that the request will not be forwarded to the unhealthy instances. It will only make forward the traffic to the healthy instances. Then it provides the SSL termination for your website. It enforces the stickiness with the cookies, uh, high availability across multiple availability zone, and with the help of load balancer, we can separate public traffic from the private traffic. So we are going to see all of these use cases in the upcoming slides. Now, why to use an elastic load balancer? Now, what is the elastic load balancer? Elastic load balancer is a load balancing service offered by AWS. Okay, so elastic load balancer is a managed AWS service. If we are using the elastic load balancer, we can get rid of multiple operational and setup tasks, and AWS guarantees that it will be working. So there will be no downtime for your load balancer. Otherwise, sometimes what happens is if you're using your own load balancer on premises, then sometime your application is up and running, it is working fine, but your load balancer goes down. So how you are going to get the traffic if your load balancer is not available? And AWS take care of the upgrades, maintenance, high availability, all the operational aspect of your load balancer will be taken care by the AWS. And AWS provide a very few but very effective configuration knobs. It means you do not need to worry about at the hardware level configuration. You need to provide only the your application level configuration. Okay, so it is like it costs less to set up your own load balancer, but on the effort side, it will be like a lot more effort uh, on your end. And the extra advantage of Elastic Load Balancer is that it is integrated with many AWS offering, many AWS services such as EC2, Autoscaling Group, Amazon ECS, EKS, Lambda, Certificate Manager, CloudWatch, Route 53, BAF, Global Escalator, multiple services also. So that is why we will prefer using the Elastic Load Balancer. Health check I will come later on, but let's get an understanding. Now health checks are very crucial for the load balancer. So if let's say there are multiple, so the whole purpose of the load balancer is it is doing the load balancing across. So let's say this is your load balancer, okay, and these are your EC2 instances. Now it will get the request from the end user and it will send the request to your downstream servers. So let's say I'm running a web server which is running on port 80. Okay. Somehow the web server on this website goes down. Then it will not send the traffic here. It will not send the traffic here. And how the load balancer will come to know that I do not need to send the traffic to this server 1, because it is constantly checking the health of your application running on the server. At any time, health check is failing. Anytime health check is failed, then it will stop sending the traffic to the underlying server. Okay, so they enable the load balancer to know if instance it forward traffic to are available to reply to request. The health check is not done on the port, is done on a port on a route. If the health response is not okay, that is a 200 status, then the instance is unhealthy and load balancer will stop sending the traffic to the underlying downstream server. So that is why health checks are very important in case of load balancing. Now there are different type of load balancer available in AWS. So we have a classic load balancer, we have an application load balancer, we have gateway load balancer. Classic load balancer is the old generation and it has discontinued now. So we will not use the classic load balancer. We will use the newer kind of load balancer, that is the application load balancer and the network load balancer. Overall, it is recommended to use the newer generation load balancer as they provide more feature. Load balancer again can be set up as the internal or as the external. Now, how to do this? Again, with the help of security groups. So load balancer will also surrounded by the security groups, and we can define the routes and rules in those security groups to allow the public traffic or the internal traffic only. So this is just the basic of the load balancer. So with the help of load balancer security groups, we are going to let's say if we are allowing 0.0.0.0, then it is a public load balancer. Otherwise, it will be an internal load balancer. Okay, so this is just the very basics of the load balancer. We will do the hands-on from tomorrow on the load balancer, understand what are the classic load balancer, what are the other type of load balancer. Then we will deep dive into the application load balancer and the network load balancer. So that we will continue tomorrow. Any question do we have? I can address those.
No, fine. I think I have a question tomorrow, like difference between the application.
Correct.
Yeah.
Right. Whenever we will be doing the hands-on.
Yeah.
And Abdullah, you asked one question, spot request, like how to do the combination of on demand and the other one. I found that, but at the moment I again missed it. I will like create a note out of it and will share it with by tomorrow. But I have found it.
Thanks.
Okay. Yeah. So yeah, this will be it for today's session. We will meet tomorrow.
Thank you.
Good night. Thank you.
Good night.